Okay, an easy one today. Had a nice break. Gave up on a medium. Gave up on a falling hard one that was just the same but harder. Anyways, complement of base 10 integer. The complement of an integer is the integer you get when you flip all the ones, all the zeros to ones, and all the ones to zeros. Sure. In its binary representation. For example, 5 is 101 in binary and its complement is 010, which is integer 2. Given integer, return its complement. Sure. I think this is XOR with all ones, I want to say. If you do XOR with all ones, it should give you that, right? Like 1 XOR 1 is 0. 0 XOR 1 is 1. 1 XOR 1 is 0. 0 XOR 1 is 1. So 1010 XOR with this value is going to be 0101. Okay, so I think this should just be return the XOR with actually, yeah. What's the biggest value? Or I'm given integer. Well, the integer is up to 10 to the ninth. 10 to the ninth is 32 bits. Log base 2 of 10 to the ninth. Is that 32 bits? Okay, 30, sure. So I think I do something like all ones is going to be 2 to the power of 30, 31 minus 1. And then I just want to do return all ones XOR, binary XOR with n. I think that's it. Hmm. What is going on? Let's say return value is equal to all ones. Is this XOR? Pretty sure the XOR function is this. Binary. Yeah. Bitwise XOR is the caret symbol. What am I missing here? 5 XOR 2. I wonder if this needs to be signed versus unsigned. Let me go ahead and check. So let's go print 5 XOR with like 3 ones. That doesn't quite work, does it? No. 0 XOR 0 should give you 0. I think I see. I think I see. It's because this thing has leading zeros. This thing has, like a 5 has leading zeros. So 5 is like that with maybe some leading zeros. I need to just have it just be the same number of bits, but ones. So I need to have leading zeros there. So the power that needs to be should be the number of bits that n contains. And the number of bits that n contains should be um, should be log base 2. Log base 2 of n. So if n is equal to 5, log base 2 of 5 is 2 point something. This is round up. I assume this is rounding down. Do 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 do. Yeah, this needs to be 3. This needs to be 3. Just the edge case. Let's check for 8. 8 should be 4 bits. So I'm wondering if this should be just bits plus 1 here. I wonder if that works. 3, 4, which is good. 10 has 4 bits. Okay, yeah. So I think this should be 2 to the power of number of bits minus number of bits plus 1 actually. Number of bits plus 1 minus 1. Do 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 do. I don't know if this is any good. Oh gosh. 10 you say, 10. How would it have gotten 10? So it has an extra 2 to the power of 3 is 8 minus 1 is 7. Actually maybe this isn't, yeah. That's fine without the plus 1. La-di-da-di-da. I think this is going to be slow because I forgot to remove the print. Or just could not work at all. Expected a positive input. Really? It could be negative, huh? Oh, it could be 0. I see. Logarithm has positive inputs. So if it's 0, that's an edge case. If it's 0, then it should just return 1, I want to say. Otherwise, it does the rest of it. Maybe remove this return value stuff. Let's see if this is any good. Oh yeah, back into the street column. Okay, so let's see. This is the example. So summary, this is going to be the logic of finding the answer where zeros, zeros and ones toggle to 1 and ones and zeros is identical to logic of XOR or bitwise XOR. Thus, can take the input n and XOR it with a value with the same number of bits but all ones. So for example, let's say 1010 XOR with 1111 to find the answer. Use log value base 2 to determine the correct number of bits for the value of all ones. Then just return the input XOR that value. Also, edge case n equals 0 is handled separately. Separately, so how do you spell that? Separately, since log cannot take 0 input. Time complexity, this can be O of 1, since all work is done with constant functions, constant operations. I mean, taking a logarithm, yeah, I think you'd consider taking a logarithm a constant operation, right? Space complexity, this is going to be O of 1, since no extra space is needed.